In this video, we explain the IQ Power Spectrum block. First, build a simple mission. In the Blocks panel, double-click the Spectrum block. It appears in the main editor window and opens its configuration on the right. Next, add the IQ Power Spectrum block to the mission by double-clicking it. It automatically connects to the Spectrum block. Then, add a receiver. Double-click the Spectran V6 Eco receiver in the Blocks panel. It connects automatically, creating a simple mission consisting of the V6 Eco receiver, the IQ Power Spectrum block, and the Spectrum display block. The focus of this video is the IQ Power Spectrum block, which is always required when displaying spectra. The RF signal entering the Spectran V6 Eco receiver is converted into an IQ stream. The IQ Power Spectrum block then converts this IQ stream into spectrum information, which the Spectrum block displays. Start the measurement. The Spectran V6 Eco configuration window is not needed for the rest of this demonstration. On the right-hand side, the IQ Power Spectrum display appears in the lower panel, and the corresponding spectrum display appears in the upper panel. Open the configuration panels for both displays. Double-click the tab for the IQ Power Spectrum display. Then double-click the tab for the Spectrum display. Move the configuration panel to the right to make more space for the graphs. Set up the Spectrum display legend first. In the Spectrum configuration, set the legend placement to top center. Enable Show POI 100%, Show FFTS, and Show Rate so this information appears in the legend. Now configure the IQ Power Spectrum display legend. In its configuration panel, set the legend placement to top left. Again, enable Show POI 100%, Show FFTS, and Show Rate for the legend. The two displays now show identical legend information in different positions. Close the Spectrum configuration panel. Next, focus on the IQ Power Spectrum block and how its settings influence the displayed spectrum. In the IQ Power Spectrum configuration panel, open the main section. This section contains several parameters that directly affect what appears in the spectrum displays. Begin with the FFT size mode set to FFT. Reduce the FFT size to 32 and observe the change in the spectrum. The IQ Power Spectrum block drives the spectrum display, so changing these settings immediately affects the spectrum shape and resolution. Increase the FFT size again, for example, back to 1024 as a more typical setting. Switch the FFT size mode to bins if measurements are easier to interpret in terms of bins. Adjust the bin slider and watch how the spectrum changes in response. For more control over resolution bandwidth, select New FFT as the FFT size mode. The default FFT RBW frequency is 100 kHz. If the measurement requires a resolution bandwidth of about 30 kHz, set the RBW frequency accordingly. This is where to configure the Spectrum Resolution Bandwidth filter via the IQ Power Spectrum block. Different FFT windows are also available. Open the FFT window dropdown. The default selection is the Hamming window. Change the window type to Blackman and observe its effects on the spectrum. Alternatively, select a flat top window when more accurate amplitude readings are needed. Each change in FFT window is reflected in the spectrum analyzer display, showing how window choice affects the measured spectrum. This video has demonstrated how the IQ Power Spectrum block converts IQ data into spectrum data for the spectrum block, and how adjusting the IQ Power Spectrum settings directly changes what is seen in the spectrum displays. For more information, check out our other videos on our YouTube page or visit erroniausa.com. And if you have ideas for other videos you'd like to see, leave us a comment below.